Hey YouTube, this is FarWizard23, and I decided that starting with this video, I'm going to start making a couple math-related videos to discuss just some of the ideas and stuff that I have about like certain mathematical proofs and theories and stuff. It's a bit of a different flavor than what's used to on my channel. I hope everyone likes it, especially the people in high school. I would definitely be watching these videos because I think you'll learn a lot from this. The first thing I'd like to talk about today is triangles. Let me get a triangle going here. Okay. Got ourselves a triangle. And I'm going to go ahead and create a line extending this base here. Doesn't look like it, but that's supposed to be a line just directly extending this straight base. I think everyone can accept that, okay? Let me go ahead and mark the angles of this figure. Okay. So here's A. Here's angle A. Here's angle B up here. Call this one angle C. And I'm aware of the fact that there are like math programs I can use that would actually help me with this, but this is just the easiest way to do it now. So we've got angles A, B, and C inside the triangle, and we got this angle D on the outside of the triangle. Okay? So let's create just some basic formulaic ideas. Okay, everyone knows about triangles, right? That the measure of angle A plus the measure of angle B plus the measure of angle C must equal, class, what's that equal? Right, 180, because it's a triangle, right? Alright, so, and I apologize for the symbology. I'm trying to create the angle symbol, but I don't have that available on the keyboard. So, that's great. So we know the interior angle measure of a triangle must be 180 degrees. Everyone, that's pretty well-known mathematical fact. Let's look at angles C and D now. They are what are called supplementary angles. So the measure of angle C plus the measure of angle D must also equal 180, because it's a set of angles created from on the base of a solid line. Their total measure must be 180. Now, where else can we take that? Well, let's think about this for a sec. If this top formula here equals 180, and that second formula also equals 180, then they must equal each other. So I could say this. I could say that the measure of angle A plus the measure of angle B plus the measure of angle C must equal, going to the bottom formula, the measure of angle C plus the measure of angle D. Huh. Interesting. So those two formulas have to equal each other, as I've now rewritten. Now, for those who are unfamiliar with algebraic ideas, when you're working with formulas in algebra, and you have an equation with an equal sign, you have to do the same thing to both sides if you ever want to manipulate the equation. If you add 9 to one side, you must add 9 to the other side. If you take 5 away from one side, you must take 5 away from the other side. That keeps it in balance. Like if you had a scale where it weighs exactly 500 pounds on both sides, if you want to keep it in balance, then you must add or subtract the same amount of weight from both sides to maintain the balance. So what if we took, since it's on both sides of the equation, the measure of angle C away from both sides? And then what we're left with is this statement. The measure of angle A plus the measure of angle B must equal, therefore, the measure of angle D. What that means is, we've not proven this for every general case based on what I've written here. So again, this kind of becomes the big highlighting point, that the total of these two angles, A and B, must equal the angle measure of D in any situation. It must be true. So for example, if A was 30 degrees and B was 45 degrees, then D would have to be 75 degrees, based on this theorem that we have now proven.